Today, we're going to learn how we can reverse an array, and then we're also going to learn more about reshaping and flattening multi-dimensional arrays in NumPy. First of all, let's look at how we can reverse any array in NumPy. So, as always, I'm going to create my NumPy array, which is going to equal np arange and pass in 10. To reverse it, we will use the flip method. So here we can print np flip and pass in the array. And as an output, what we should get is the array reversed. And this also works with 2D arrays. So here I will create an arange and reshape that to 3 rows and 4 columns. Now when we run this, what we should get as an output is a matrix that has been reversed. Just to make this easier to understand, I'm also going to print the original array, because next I want to talk about how you can reverse only the rows or columns. And as usual, to do any of that, you need to refer to the axis, which here we're going to set to 0. So now when we run this, what you should notice is that all of the rows were reversed, but none of the columns were reversed. Here we have the original, and here we have the matrix that was flipped. And once again, each row was reversed, but the columns stayed in place. Now, if you want to flip the columns, you can do so by specifying 1 as the axis. This time, the rows are going to stay in place, but the columns are going to be reversed. Now, if you want to get even more specific, you can specify which row or column individually. Here we're going to type in array at the index of 2 will equal np flip and pass in the array at the index of 2. Then we're going to print the array. And what you're going to notice is that the only row we reversed was the row at the index of 2. Everything else stayed the same. Now imagine you want to reverse the second column, which means we want 1, 5, and 9 to become 9, 5, and 1. Well, to do so, we need to specify that column. So we're going to ignore the row by adding a colon here and then passing in the column number, which is going to be at the index of 1. And we need to do the same thing here. Now when we run this, what we will end up with is 9, 5, and 1 in the new array. That was the only part we flipped. Up next, let's learn about 2 popular ways to flatten an array in NumPy. For this example, I'm going to create an array of 1s, which will be of type integer. Now when we print these 1s, what we should end up with is a matrix of 1s. To flatten this, all we need to do is type in 1s and flatten. Then we will end up with a flattened array. What's nice about this is that no matter how many dimensions you have, it's always going to flatten it to a 1-dimensional array. Also, when you flatten an array using flatten, it creates and returns a new copy. So modifying the flattened array will not affect the original. Here we can type in something called new ones, which will equal ones.flatten, and we're going to modify it by typing in new ones at the index of 0 equals 999. Right below, we're going to print ones and new ones. And when we run this, you're going to notice that it did not affect the original. This change was only applied to the flattened array. Otherwise, if you want to save memory and you don't mind working with a view of the original data, you can use the ravel method, which does the exact same thing but returns a view instead. So instead of flatten, we'll just type in ravel. Now when we run this, you'll notice that any changes to the new array will affect the original. So flatten returns a deep copy and ravel returns a view.